Hi everyone, welcome back to NEET World 2026 EAPCET series. So in the last sessions we have covered the mole concept and some basic concepts of chemistry along with periodic table and its classification and properties, right? And we have solved the questions related to those two chapters with a special discussion or a special session I can say, right? So today we will be starting the discussion on structure of atomic structure here, okay. So now there will be two questions in EAPCET from this particular chapter, okay. So now what are the important topics we have from this structure of atoms? First of all we will point out those topics first, then we will discuss everything clearly along with the PYQs, okay. So I am going to discuss everything very basic from this particular chapter, okay. Then I will be showing you questions, how they are framing the questions from this chapter and how easy they are, how tricky they are, and how we can interlink this with our JEE NEET preparation and also with even IPA exams, okay. I will tell you everything. See here, first of all we need to discuss in this chapter few things. First thing here is early discoveries, early developments we can say, okay. And after this we have atomic models. In early discoveries itself we have early discoveries or early developments where we are going to discuss about subatomic particles and atomic models, okay. These are the things we need to discuss here. And after this we have what? The de Broglie wave equation we have, and HUP, Heisenberg's uncertainty principle, and the next Schrodinger wave equation we have, and quantum mechanical approach, that is quantum numbers also we need to discuss here. And out of this all the things, the very important points as per your EAPCET exam point of view, if we discuss, there are few things to be focused here, highly highlighted topics here. From atomic models we have three atomic models: Thomson's atomic model, and Rutherford's atomic model, and the next Bohr's atomic model, right now. So from these, Bohr's atomic model must be covered here, and when it comes to this de Broglie wave equation and Heisenberg uncertainty equation, these two are there. And here, in order to understand this Bohr model, there will be discussing about spectra and all. So before going to that, here we will be discussing about electromagnetic radiation, and you know there will be some discussion of particle nature where we will be discussing about particle nature. And particle nature, here we will be covering Planck's quantum theory. What is that? Planck's quantum theory and photoelectric effect. So there are many questions asked from this photoelectric effect, okay. So especially photoelectric effect should be covered here. And you know, same topic, Planck's quantum theory, black body radiation, and next photoelectric effect you will be studying in physics also. So same topics will be coming here, okay. Especially photoelectric effect must be covered here itself, okay. And the next, because there, if you observe from last 10 years of EAPCET papers, MCET papers, you will be seeing questions either from Bohr's model, Planck's quantum theory, or this photoelectric effect, and the next de Broglie wave equation, Heisenberg uncertainty principle, and the next this quantum numbers, that's it, okay. So these are the important topics to be focused. Now anyways I am going to discuss everything here, but we will focus more effectively on this Bohr model, photoelectric effect, quantum numbers, and this HUP, okay. Let's start our discussion here. Look at this, how the questions are framed. Look at this very basic question first. See, this is what very basic question asked on who discovered, early discoveries are there now. So who discovered and what they discovered, okay. So now you can answer this without wasting your time. Once after explaining few things about that subatomic particles. Okay, let me start the discussion of the structure of atom here. Right, look at this. We know atom means what? Atom means it is a small indivisible particle. We cannot divide that particle. That is what atom meaning, right? So but later it means at early stages they considered that atom is the smallest particle that we cannot divide further. But later on we got to know that atom also consists some particles which we can call it as subatomic particles. Okay, so now what are the subatomic particles we have in an atom? Yes, so look at this, we have electron, proton, neutron. So atom consists of majorly electron, proton, neutron. Along with these we have some other mesons and all other things, but we will be focusing on these three particles. So atom, now what we got to know, atom consists of subatomic particles like electron, proton and neutrons got to know. But how these particles were arranged in an atom, that we haven't got now. Yes, so to explain or to prove that atoms, electrons, neutrons are present in an atom and how they present, there are different ways or different experiments were done by the different scientists. Let us look at their efforts. What are the efforts they have given and how do they explain? See, the first person here is J.J. Thomson atomic model we have. The next Rutherford's atomic model we have in order to explain the atom, how these particles are arranged in them. Okay, and the next Planck's quantum theory, de Broglie hypothesis, Heisenberg uncertainty principle we need to discuss. Okay, so first one, the electron early discoveries. Here it comes electron. So who discovered electron? J.J. Thomson. By what experiment or in what way he discovered this? By using a cathode ray tube experiment. Okay, so this is a cathode ray tube experiment. I mean, what he taken is, in this tube he just subjected a gas, he taken a gas in this with maintaining very low pressure, and he applied electric field like high energy electricity is passed through that. So now what happens, that gas got ionized, like G place, and electrons are released. So these released electrons, now what they did, so they are passing, they are going towards positively charged plate. It means electrode which is having positive sign here, so they are moving towards that positively charged electrode. So now what they got, so the particles which upon released by ionization of a gas might be negatively charged, that's why they are moving towards positive electrode. Okay, and they consider these rays which are coming from this cathodes to anode considered as cathode rays. So cathode rays originate at cathode side and moves towards anode. Okay, so this is what he considered. Now what he considered is, by doing some experimental observation, by putting a fan, like a pedal I can say, which can rotate like a fan. So now what happens when these particles are hitting on the pedals, now what the pedals are rotating now. So from this what he considered, these electrons which are having which are moving in a straight line direction from towards this negative positive sign, therefore they are negatively charged and they have particle nature. What nature? They have particle nature. Okay, that's why the paddle is moving here like that. He concluded some outcomes. Now later here, for exam point of view, the main points here to be focused here is, what is the charge of an electron, what is the mass of an electron. This is what asked in the exam. So let me tell you what is the charge of an electron and mass of an electron here. See, here we have Millikan oil drop experiment, which is used to give the value of charge of an electron. So what is the charge he found using this Millikan oil drop experiment? See, charge of an electron is considered as 1.602 into 10 power minus 19 coulombs. What is the charge of an electron? 1.602 into 10 power minus 19 coulomb with a negative sign. Okay, and what is the mass of an electron? Again, by using this value and charge to mass ratio value, so the mass of an electron were found to be 9.11 into 10 power minus 31 kg. Okay, this will be the value of mass of an electron. So you need to remember this subatomic particle charges, their mass and charge to mass ratio, because based on this also we have few questions. I will show you everything. See, what is the charge to mass ratio? 1.75 into 10 power 11 coulomb per kg, and a charge of an electron through oil drop experiment, how much we got? 1.6 into 10 power minus 19 coulomb. So from this we can find mass of an electron. Okay, mass of electron is 9.11 into 10 power minus 31 kg. Okay, similarly if we have anode ray tube experiment which is done by Goldstein. So where he given the mass of an electron, I mean from that experiment what he got to know, so protons are positively charged particles. So this was observed when in that tube, when he considered, in the discharge tube when he considered hydrogen gas and he analyzed that. So he got the H plus ions which are having positive charge, these are considered to be protons, and other gaseous ions are not protons, they are just gas, whatever the gas taken, that gaseous ions. See, I am not giving complete theoretical information because most of you are knowing about the subatomic particles, right? Okay, so just I am giving you the important glimpses there. Okay, and you know already on the structure of atom in this channel itself I have made multiple videos. Okay, so now if you want complete detailed information you can watch it, and here I am giving you what are the important points in this EAPCET exam point of view. Okay, so focus here, anyways you are going to get complete idea, so just read these statements, those are very important points which are included here. Okay, along with my whatever the lecture I am saying here. Okay, so this proton, when hydrogen gas is taken, whatever the positive charge coming out of that hydrogen gas is considered as proton. Okay, so now what is the mass of this proton and what is the charge of this proton? So again, so charge of this proton is same as charge of electron with positive sign, 1.602 into 10 power minus 19 coulomb, and mass of this proton is 1.674 into 10 power minus 27 kg. So these values are very, very important. So again they will ask charge to mass ratio of electron, proton, how do we give the ratio of this charge to mass ratio of electron, proton, neutron. This is the way they may make the question. Okay, and these are the properties of anode rays. Okay, right. Next, so what I told you, mass of electron, mass of proton is 1.672 into 10 power minus 27 kg, and mass of proton is done, and charge of proton we got same as charge of electron with positive sign I told you. Okay, so now out of these two values, mass of proton, mass of electron, which is more? Mass of proton is more. Similarly we have to know the mass of neutron also here. Okay, so mass of neutron is almost near to the mass of proton but slightly greater, I will tell you. And who discovered the neutron? Thomson is for electron, Goldstein is for proton, and for neutron we have Chadwick. Okay, so by doing a reaction, say discovery of neutron by Chadwick, James Chadwick in 1932, what he did, so he taken beryllium. See, beryllium, this is a nuclear reaction we can say. So 9 is a mass number, 4 is the atomic number of beryllium. He bombarded this beryllium atom with helium nucleus. Helium nucleus also considered as, this is also considered alpha particle. So now what he got is, see, just look at here what I am writing, C12 I am writing. So C12 is nothing but 9 plus 4, how much? It is 13, not 12 I am writing, and 9, like here I am writing a symbol eta, okay, and with number 1 here, and 4 plus 2 is 6 here, and this will be 0. See, 6 here, 6 plus 0 is 6 here also. See, we got a new particle having a mass as 1 and charge as 0, and here protons are 6, therefore 6 I have written, here 2 and here 4. For beryllium 4 protons are there, na? That's what. Okay, for neutron there is no proton, there is no electron in it, it is just having the mass of 1 unit. Okay, I can say this newly generated particle as a neutron. So who discovered this? James Chadwick here. Okay, and mass of this neutron is 1.677 into 10 power minus 27 kg. Okay, whereas mass of proton is 1.674 into 10 power minus 27 kg. See, slight change. Mass of neutron is greater than mass of proton. So there is a question asking what is the ratios of mass of electron to proton, proton to neutron. Like this we have a question. I will show you, just look at this. See, mass of proton can be written as 1837 times of mass of electron. Similarly, mass of neutron can be written as 1840 times of mass of electron. So from this what we can say, mass of neutron is greater than mass of proton, which is greater than mass of electron. So this relation, based on this we have a question, I will show you. Okay, right. So this is the conclusion we can get from those discussion. Okay, and look at these. Now we got to know there are three subatomic particles like electron, proton, neutron. Now how do they arranged in an atom? Yes, so for explaining this we have Thomson's atomic model. Okay, as per this Thomson's atomic model, he considered it as a watermelon model also. Like what we can say, watermelon contains that red color plum in which seeds are embedded, right? So in the place of seeds he consider electrons. Okay, and what that red color part plum is there, na? So in the same manner the protons are uniformly distributed in which electrons are embedded like seeds. Okay, therefore electrical neutrality of atom is maintained. So this is what he told. But later on, when Rutherford did one alpha scattering experiment, this theory, this atomic model got failed. Why? Because what he told, see, this atom contains positively charged which is uniformly spread throughout the atom he is saying. But when this Rutherford did his alpha scattering experiment, so alpha scattering experiment is nothing but alpha particle he has used. It has a charge of +2. So now if positive charge is spread uniformly throughout the atom, so this particle should not enter into the atom now. So but they are smoothly going into the atom and coming out of that atom. So this should not happen, but it is happening. It means his atomic model is got failed. Okay, this is what the first attempt, but it got failed because of Rutherford's alpha scattering experiment. Hope this is clear, right? Okay, so what I told you in Rutherford's atomic model, whatever the experiment he taken, here you can see arrangement. See, he has taken a gold foil here. So through that he is using some radioactive source where it will releases alpha particles. What it will releases? Alpha particle which is having charge of 2 and having mass of 4 units. Okay, so now because it has 2 protons in alpha particle, we have 2 protons. Okay, so now what happens is, if this is a positively charged species, that should not go through the positive charge towards the positive charge. Now it should deflect from the like charge. Okay, it means that's why the Thomson's atomic model got failed. So here he has considered a gold foil here. So through this gold foil he is passing this radioactive helium like alpha particles. Now that alpha particles are coming out, are entering through this gold foil without any deflection. Most of the alpha particles are coming out without any deflection. Okay, but very few are having some deflections, and like 1 in 20,000 I can say, very few are having like exactly opposite direction, I mean retracing its original path and going back. So very few are going in that manner. So it means that, see, this gold foil, this atom also contains a small portion in which positive charge might be placed. In that position only, if these alpha particles are also going, then the deflection or the retracing of its original path is observed. But remaining other position is what? It is a hollow space where there is no protons. So these alpha particles are coming out without any deflection. This is what he observed here. Okay, right. So from this, what he considered, so he considered that the atom has a radius of around 10 power minus 15 meters, 10 power minus 10 meters atom size, okay, having radius this much. Then there is a small portion called nucleus having size of 10 power minus 15 meters. Okay, so this nucleus is nothing but a positive charge concentrated at a point. That point is called a nucleus. Okay, if any alpha particle is entering through that nucleus, it is not allowed, so it will be retracing its original path and going back or having some deflections. Okay, and remaining space is halo, okay, empty space he considered. So this is what he told. And the next one here is, there are some limitations. What are the limitations? See, first of all he told atom is having a small portion where positive charge is concentrated and remaining space is halo, okay, and atom is completely overall neutral. What he said, electrically neutral, okay, and number of electrons present in an atom will be equals to number of protons, okay, to balance or to maintain electrical neutrality. And next one here is, see, what are the drawbacks of Rutherford, you tell me? See, he just told that positively charged concentrated at a center called nucleus, like this he considered, right? But he is not explained reasons for stability of atom. What he was not explained, stability of atom is not explained, and stability of atom is not explained, and atomic spectra is not explained. These are the main drawbacks, that stability of atom and atomic spectra is not explained. Okay, and then next look at this question. Match the following. See, these are the things discovered by whom? See, Chadwick, discovery of neutrons, right? And the next Rutherford, what he did? Rutherford, and the next Moseley and J.J. Thomson. So J.J. Thomson did cathode ray tube experiment. Rutherford nuclear atomic model, just now Rutherford gold foil experiment we studied now. So this is 4. And the next Moseley X-ray spectra, right? This is a question we have in EAPCET. Hope you have got clarity over our discussion and this question also, right? Next, let us move forward. There are few special terms in this structure of atom to be discussed. Okay, so first one is atomic number. So what do we mean by atomic number? So it is given by, in an atom, atomic number will be equals to number of protons present in it or number of electrons present in it. For an atom, atomic number will be equals to number of protons present in it or the total number of electrons present in it for an atom. Okay, whereas for ions, whether it can be a cation or anion, see, its atomic number will be equals to number of protons only, because when it is forming an ion, the ion formation takes place by gaining of electrons or by losing of electrons. So it means electron count might be changed when it is converting from atom to ion, but proton count remains same. That's why atomic number always equals to number of protons. Okay, for example, sodium atom, if I say it has 11 protons, 11 neutrons. If I say sodium ion, Na plus, if I say, so one electron is removed from sodium atom, therefore it is becoming Na plus. It means its atomic number will be now equals to 11. Why? Because it has protons as 11, but electron count here is 10 only, because one is removed now. That's why it is becoming Na plus. So always remember, atomic number is given from its number of protons, whether it might be atom or ion. Okay, hope this is also clear, right? If the things are clear, just click on the like button and just stay connected with the channel. See, you just watch till the end, so that you will get complete clarity what we are discussing here actually. Okay, right. Next, there is one more thing called mass number given by symbol A. Okay, so for example, I am indicating an element with symbol chi. So here I can indicate its atomic number Z and mass number A. Okay, so this mass number A can be given as A is equals to number of protons plus number of neutrons in it. number of protons plus number of neutrons in it, that gives what? The mass number of a particular element. Okay, right. For example, sodium contains 11 protons and 12 neutrons, therefore its mass number becomes 12 plus 11, that is 23. So here you can write 23 for sodium. Okay, so the below number indicates atomic number, above number indicates mass number, right? Next, yeah, so there are some terms related to this number of protons, neutrons and their ratio, difference, all these things should be considered. Based on this, we have one question I am going to show you. Before that, you understand this. See, there are some terms called isotopes, isobars, isotones, isoelectronic species. First isotopes. What do we mean by isotopes? Tell me. So isotopes means, see, carbon having 6, 12, carbon with 13, 6, I am writing. So their atomic number is being same, see here, but their mass number got differ. Okay, so it means species having same atomic number but different mass number are considered as isotopes. Okay, so why do they differ their mass number? Because number of neutrons are differ, number of neutrons are not same here. So number of neutrons here are 6 and here are 7. So due to differ in their mass number of neutrons, their mass number is varying. So due to this reason, the relation between two things like carbon 12, carbon 13 is considered as isotopes. I hope it is clear. Okay, so right. Next, similarly for hydrogen also, hydrogen 1 I can write, hydrogen 1, 2 I can write, hydrogen 1, 3 I can write. Okay, so now these 3 are the isotopes of hydrogen, but their relative abundance is varying. So in the nature there is maximum percentage of hydrogen 1 which is considered as a proton. Okay, which is considered as normal proton, protium we can say, and this is called deuterium and this is called tritium we can say. Okay, and whereas this tritium is there now, this is radioactive isotope of hydrogen. Okay, what I am saying, tritium is radioactive isotope of hydrogen having very small extent of availability. Okay, right. Next, what we have, isotopes is over. Next, isotopes is done. Next, isotones and isobars. See, isobars means species having isobars having same mass number but different atomic number. Atomic number is different but mass number is same. Okay, so you can take some examples here. Look at these examples. See, species having same mass number but different atomic numbers. Look at these examples. See, argon here given as atomic number 18 and potassium as 19, but their mass number is 40 and 40. So same mass number, different atomic number, then those are considered as isobars. Okay, hope this is also clear. Isotopes is clear, isobars is clear, and the next isotones. Isotones means what? Same number of neutrons, species having same number of neutrons. Okay, right, we will be seeing here. Look at this. Isotones means how they differ. See, atomic number is different but having same number of neutrons here. See, so how do you get this number? So you just take atomic mass number minus Z. See, A represent mass number, Z represent atomic number. Now A minus Z gives number of neutrons present in it. So if that n value, A minus Z value is same, means we can say them as isotones. Based on this, we have one question, I will tell you, I will show you. Okay, right. And isoelectronic species means what? Species having same number of electrons. So look at this, O minus 2 is given, F minus is given, and N minus 3 is given. See, atomic number of fluorine is 9 with one negative charge. So 9 plus 1, total 10 electrons are there here, and oxygen atomic number is 8 having minus 2 charge. So 8 plus 2, again 10 electrons are there, and nitrogen having 7 atomic number and having minus 3 charge. 7 electrons plus 3 electrons, total 10 electrons are there here also. So species having same number of electrons are considered as isoelectronic species. Okay, right. Now look at the questions. Match the following species with the correct number of electrons present in it. What is the atomic number of beryllium? Beryllium atomic number is 4 now. So 4 atomic number, but minus 2 charge, plus 2 charge is there. It means remove 2 electrons. Therefore total number of electrons present in it, how many now? 4 and remove 2 electrons, that's why plus 2 indicates removal of 2 electrons. Okay, yeah. So out of 4 electrons, remove 2 electrons, we have 2 more electrons, so A3. Next, hydrogen atomic number is 1 having charge as plus 1. So remove that electron also, it becomes 0. So B1. Next, sodium atomic number is 11 having charge plus 1. It means remove 1 electron. So its atomic number is total number of electrons are 10 here. So this C3. Next, magnesium atomic number is 12 having just plus 1 charge. So remove 1 electron. So it becomes 11. D4 like this. So based on this, whatever the option we have, you can tick that. Okay. So look at this, A3. A3 we have only in this option, and B1, yes, option D will be perfect answer for this question. Hope this is clear. Right, let us move forward. Look at this, the number of protons, neutrons and electrons in 613 carbon. Yes, very easy here also. So tell me, how can we answer this? C613. So tell me, atomic number here is 6, atomic number is 6, and number of protons, neutrons they are asking. So what I told you, to find number of neutrons, you take atomic mass minus atomic number. Mass number is 13 minus atomic number is 6. So this will be 7. Okay, number of neutrons are 7. And number of electrons are how many? If for an atom, number of electrons, protons equals to its atomic number, no? So 6. Okay, yes. So 6, 7, 6 will be our answer. 6, 7, 6, first option will be our answer for this basic question. Next, look at this. Yeah, so this is based on our discussion of special terms, isotopes, isotones, isobars, this thing. See, in the 2 elements, see they have given symbol of 2 elements mentioning that A, Z1, M1 and B, Z2, M2. The following relation are true. M1 is not equals to M2. They are saying M1 is not equals to M2 and Z1 is not equals to Z2 they are saying. Okay, but M1 minus Z, see mass number minus atomic number of both of them are equal. It means mass number minus atomic number is nothing but number of neutrons only. No, species having same number of neutrons but different atomic number or different mass number is considered as isotones right now. So we got our answer. These two species are isotones. So option 1 isotonic we can answer. Hope this is also clear. Right. Next. Now few more things to be discussed here. You know, electromagnetic waves are there now. Yeah. So we need to in order to understand this Bohr's atomic model and spectra and all those things, we need to have some clarity over this electromagnetic radiation. See, these electromagnetic radiations are nothing but form of energies which propagates with perpendicular electric field component and a magnetic field components. They are perpendicular to each other and perpendicular to the propagation of that wave. Okay, so if this wave is traveling in this direction, for example electromagnetic wave is traveling in this direction. So to this the perpendicular electric field component will be there and a perpendicular magnetic field component also be present here. Okay, like this you can understand. See, perpendicular electric field, magnetic field. Okay, and you know in order to indicate these we are using waves. So what is a wave? See, a wave consists of two parts. One is crust, other one is trough. So the whatever the height we are seeing or depth we are seeing here, that is called its amplitude, and the distance from one point to another point here, distance between two crusts or two troughs, we can say it's a wavelength lambda. Okay, or one crust and one trough includes totally considered as one single wave and its length as a wavelength. Okay, indicated with a lambda. Okay, so bigger the wavelength, lower is its frequency. So what is this frequency? We need to understand. And you know, these electromagnetic waves does not require any medium to travel. It means they can travel in vacuum also. Okay, and they do not deflect in presence of electric field or in presence of magnetic field. Okay, right. So next here, so what do we mean by velocity, frequency? We can say the number of waves passing through a point in 1 second. Okay, so for example if I highlight a point here, so there is through these points how many waves are traveling per second are considered as its frequency. Now look, smaller the size of that wave or smaller the length of that wave, more will be the frequency now. So we can relate frequency is inversely proportional to wavelength, and I can remove this proportionality, we can get a constant indicated with C by lambda. So now what is this C indicates here? This C is a constant having the or indicating speed of light. Okay, because electromagnetic waves these are having a speed of light now. So this is how much? So you can take 3 into 10 power 8 meter per second. Okay, so this is what you can consider here. And what is the units for frequency? Hertz. Hertz can be also written as second inverse. Okay, right. And we have one more term called here electromagnetic spectrum. So what is this electromagnetic spectrum here? See, when the electromagnetic radiations are arranged in the increasing order of wavelength or decreasing order of their wavelength or frequency, see, we need to arrange based on increasing or decreasing order of their wavelength or frequency. We will get a series of energies, right? Those are considered as electromagnetic spectrum. Okay, next, look at this. We have different energies here. You can observe this. We have in electromagnetic radiations, we have gamma rays, X rays, UV, visible, IR, micro, radio, and microwave, radio waves. We have like this now. So what are the energy order they will ask? You can remember this: gamma rays, X rays, UV, next UV, visible, IR, radio, micro. This is the order of the energy. Gamma rays is having highest energy. See, if highest energy, maximum frequency, maximum frequency I am saying minimum wavelength you can write, and maximum wavelength for microwave. Okay, and we have visible spectrum in between UV and IR region, you can remember like that. Okay, so in this visible spectrum we have VIBGR colors now, right? So VIBGR means red color will be having maximum wavelength, minimum frequency. Okay, and violet will be having minimum wavelength, maximum frequency. Right, so this is the energy and wavelength order you can remember. Next, look at this, the radiation with maximum frequency out of these 4 options. Tell me, just now we discussed X-rays out of these 4, first of all we know gamma, the next X-rays. So option A will be perfect answer for the question. Next, look at this, an element in +2 oxidation state has 24 electrons. See, there is an element X having atomic number 24 with +2 charge. It means 2 electrons are removed, so that it will be having atomic number will be remains same 24, but it will be having 22 electrons only. Previously it has 24 electrons. Okay, that atomic number of the element has the atomic number of element and number of unpaired electrons present in it respectively are. So what is the atomic number? Atomic number will be remain same only now. 24 see, +2 state has 24 electrons. Okay, see, read the question once again. An element in +2 oxidation has 24 electrons. See, if there is an element having +2 charge, it means 2 electrons are removed from it. Okay, so 2 electrons are removed. Now it is having 24 electrons. 24 electrons. It means before how many are there? When it is +2, it has 24. If it is 0 charge here, it should have 26 electrons now. It means in its atomic state, it is having 26 electrons. So its atomic number is 26. Okay, and in +2 state, 24 electrons are there. Okay, here also atomic number remains the same. Okay, now atomic number is 26, and what is the number of electrons which are in unpaired? I hope you know basics about electronic configuration. Generally atomic number 26 means what we know, it is iron. Okay, Fe. So what is the electronic configuration we can write? So argon 18 is over, all electrons are filled. Next 3d 6 4s2 configuration we have 18 20 26 over, right. So now write their electronic configuration +2 now. +2 means you remove electrons from here. So we have 3d6 electronic configuration, 4s0, 1, 2, 3, 4, 5, 6. So how many unpaired electrons you are seeing? 1, 2, 3, 4. So 26 atomic number with 4 unpaired electrons. So option 2 will be perfect answer for the question. Hope this is also clear, right. This is done already, we have solved that question. And look at this isoelectronic species question. See guys, every question which I am discussing are PYQs of EAPCET only. Okay, so you can watch with full confidence that you can easily crack EAPCET if you follow this session regularly. Okay, right. Find the correct set with isoelectronic species. See, again very simple question, just count the number of electrons. See here, in this we have ozone, like O2 molecule is there. O2 is having 16 electrons. 16 electrons here. This is 16 electrons, but this F minus means 10 only. Here also 10. So this is not the correct one. So N minus 3 means 10. Magnesium plus 2, 12 minus 2, 10. This is also 10. So option C will be perfect answer for the question. If you want, you can verify for others. Yeah. Next, we have black body radiation. So what do we mean by black body here? It's an ideal body which can absorb or emits all types of radiations at all temperatures and you know ideal body is an hypothetical one. Okay, right. So this will be the variation of intensity with a wavelength. Okay, see at higher temperature we have maximum intensity you can consider, so again it decreases. Okay, and then next at lower temperature this is the case. Next, Planck's quantum theory. So what he says, energy cannot be emitted if this is a black body or an ideal body you can consider. So energy cannot be emitted or absorbed continuously, but it happens in a discontinuous manner like this. Okay, so each of this packet of energy is considered as quanta. What is that? Quanta. See, energy cannot be absorbed or emitted continuously, but it is happens in the form of small packets like this called quanta. So quanta in case of light is considered as photons. Okay, so we can say quanta as photons in case of light. So now the energy of each quanta can be written like this: E is proportional to the frequency, okay, of that emitted photon. Okay, so now E is equals to H. I am removing this proportionality, I am replacing with H. It's a Planck's constant given as 6.626 into 10 power minus 34 joule second. Okay, right. Next, this is for one photon. If I have n photons here, what we can write? E is equals to nh nu. And what is the relation with wavelength we have? E is equals to nhc by lambda we can write. Okay, so these are the formulas to be noted here, and very basic. We will be seeing many questions on this also. Okay, and these are very fundamental to understand other concept like photoelectric effect especially. Okay, right. Now here let me show you one simple question. Answer me with this. Look at this first. Answer me with for this one. So how can you calculate energy of a given photon? So E is equals to, photon is having this much wavelength. So hc by lambda we can use, and h is 6.6 into 10 power minus 34 joules second, multiplied with c is speed of light 3 into 10 power 8 meter per second you can take by, and what is the wavelength given? 3000 angstroms, or I can take 3000 angstrom, 1 angstrom 10 power minus 10 meters. Why we are taking in meters? Already data is in meters, jo SI units now follow that. Okay, and remove this thing. Next, our answer is in terms of joules. Yes, energy units are joules now, that is correct. And these we can write 3 zeros are there, 10 power 5, and this will be removed. So we got 6.6 into 10 power minus 5, it means 29, here I can write 9 joules. This will be the answer in terms of joules. Okay, and you can answer me for this one. When I take 6000 angstrom, what will be the answer? Now tell me answer for this question. This is a PYQ question, that is previously it is a very basic one, and now tell me further. Calculate the wave number frequency of orange radiation having wavelength this much. So very easy, wavelength is given. So what is the relation with the frequency? Frequency I can write nu, which is equals to c by lambda I am saying. And what about this wave number here? Wave number means wave number nu bar I can indicate as 1 by lambda, that is inverse of wavelength. Okay, right. So these two things if I consider, wave number first 1 by lambda, that is 6300 angstroms. See, all options are in meters, so meter inverse. So I can write here angstrom as 10 power minus 10 meters. Okay, this can be again simplified as nu bar is equals to 6300 10 power 10. So 10 power 10 I can write 10 power 10 meter inverse. See, 2 zeros are removed, so it becomes 10 power 8. So 10 power 8 I am writing 100 into 10 power 6 by 63 meter inverse. So this will be around 1. See, there are all options having same value. It means 1.587 nu bar how much? 1.587 into 10 power 6. So we have 10 power 6 in these two options. So option might be here in these two, and verify this. Nu bar will be equals to 3 into 10 power 8 meter per second by c is given written, and then next what is that? Lambda is given as 6300 into 10 power minus 10 meter. Okay, right. Next here we can write this as 10 power 6, and this will be 21, and here I am writing second inverse as a unit. See, I can write this on the numerator, it becomes 10 power 16 it becomes. So I can write this as 10 power 14 into 100. Why I am writing like this? 100 by 21 means we can easily simplify it, so that it will be around see all of the options are same again, so it will be 4.761 into 10 power 14 second inverse. So second inverse can be also given as hertz also, okay, right. So looking at the options, yeah, this is 14, so it means option C will be perfect answer for the question, right? Right. Next, move for the next question. So what is this photoelectric effect? We have discussed about Planck's quantum theory. Now it is time for photoelectric effect, again very important. There are many questions, I just wanted to show you once before solving it. See, this is a question from photoelectric effect, and these are the questions. First of all, understand the concept, then you can easily answer this question. So photoelectric effect means there will be a metal surface. On this metal surface, metal atoms will be there now. So in these metal atoms there will be valency electrons, right? Okay. So now what happens is, when a suitable amount of energy is supplied to this metal surface, this ejection of electrons will be takes place. When it will be takes place? When a sufficient amount of energy is incident on a metal surface, ejection of electrons takes place. Okay. So this complete process is called photoelectric effect. That ejected electron is considered as photoelectron. Okay. So for example, for ejection of this electron, let us say we required 15 electron volts of energy. Now if I supply only 10 electron volt of energy, will the reaction, will this photoelectron ejection takes place? No, no photoelectric effect is observed. But if I supply 15 or 17 electron volt of energy, yes, now energy supplied is greater than the required energy now. So that required energy is considered as, this 15 minimum amount of energy is considered as work function. What I am saying? Work function. So if the incident energy is greater than this work function, whatever the extra energy is there, that is used by that photoelectrons for its kinetic energy of that photoelectrons. So I can say, if supplied energy is greater than this is threshold energy or threshold frequency here, photoelectric effect can be taking place. And even if the supplied energy is equals to the threshold frequency or threshold energy, then also photoelectric effect is observed. Okay, there are three conditions. Okay, first of all, let us make a formula here. So amount of energy supplied, E supplied will be equals to work function indicated with phi, and what I told you, if any extra energy is sent, that will be utilized by that photoelectrons to convert into its kinetic energy. So kinetic energy of that photoelectron. So energy supplied utilized for work function, that is the minimum amount of energy to eject the electron from the metal surface, and if any extra energy is there, that will be utilized by that ejected electron for its kinetic energy. That's it. Is this clear or not? Right. Okay. After this, I can also indicate this energy as h nu from Planck's quantum theory, and this work function is nothing but it's energy, like energy only, the minimum amount of energy required to eject the electron, I am saying. So that is also energy indicated with h nu naught. Okay. So now kinetic energy, write as it is for some time. Okay. And we have kinetic energy formula as K equals to half mv square. So what is this v here? Velocity. So here velocity of photoelectron. If someone asks you to calculate velocity of photoelectron, you can get it from here. Okay, right. Now look at this. Now they will ask us to draw a graph frequency versus kinetic energy. What we can do? Nu equals to nu bar plus Ke by h I can write. Okay. So this is something like nu equals to 1 by h Ke plus nu bar. So y equals to mx plus c graph we can get nu kinetic energy, and graph is something like this. So what is the intercept here? We have nu bar, and slope with 1 by h, slope with 1 by h. Now look at this question. in this manner, like in this way, we can make a graph having different metals. Look at this, I am drawing 3 lines like this, nu, kinetic energy. Okay, for these 3 elements, I am indicating A, B, C lines. So match these A, B, C lines with the metals. First metal I am indicating cesium, rubidium and potassium. So these 3 elements should be inserted as A, B, C. Tell me which element corresponds to which line here. Okay, so what I told you, this gap indicates what? Threshold frequency. No? So threshold frequency is the minimum frequency to eject the electron we discussed. So now tell me which element will be easily giving the electron out? Yeah, the one which is having lower ionization energy gives electron out easily, right? So it means cesium will be having lower ionization energy, therefore its gap, this threshold frequency gap will be less here. So I can say C line is cesium and B line is rubidium and A line is for potassium, like this. Hope this is clear. Now look at this. Look at this question. What they are saying, if nu naught and nu are respectively the threshold wavelength and wavelength of incident light, the velocity of photoelectron ejected from the metal surface is. So what is the velocity of ejected photon they are asking. So very easy, just now I told you the formula, E is equals to phi plus K. So from this what I told you, E means h nu, phi you can write here as h nu naught, which is equals to kinetic energy. So kinetic energy means we can write half mv square, which is equals to h nu minus h nu naught, and from here v square will be equals to 2h nu minus nu naught I can write, and v can be written as, frequency can be written as velocity can be written as 2h into frequency minus threshold frequency to the power root it becomes. Okay, right. So do we have any option like this? No. Okay, so what we can make, the given every option is in wavelength terms, so you can write frequency equals to c by lambda, right? So replace these frequencies with c by lambda. Velocity equals to root over 2h, nu means c by lambda, here also c by lambda naught, so we can take c common, okay, and 1 by lambda, and this one 1 by lambda naught. So from these 2hc and this m also there here, c by m, we can write this as nu naught minus lambda naught by lambda, lambda naught minus lambda by lambda into lambda naught. Yes, we got our answer. Just check the options. We have 2hc by m, lambda naught minus lambda by lambda into lambda naught. So option B will be perfect answer for the question. Hope this is also clear, right? What do we mean by stopping potential here? So stopping potential means the minimum potential, minimum energy required to stop the ejected electron or to make the velocity of ejected electron as 0. It means what we need to make its velocity to be 0. If we make velocity 0, its kinetic energy also 0. Okay. You just try these 2 questions from our discussion. You can easily answer these questions, and if you have any confusions, you just mention in the chat box whatever the answer you got. I am going to explain in the next session. Okay, and in the next session we have a special discussion on Bohr's atomic model. Definitely there will be one question from this Bohr's atomic model. Okay, so there will be more chances, high chances for Bohr's atomic model or quantum numbers. Okay, so these 2 topics first from the from this structure of atom, and later on what are the priority topics? Photoelectric effect, and the next topic is HUP and Heisenberg uncertainty principle, and the next de Broglie wave equation. That's it. These are the topics to be covered. These are the 5 topics to be covered from this structure of atom at any cost. Okay, these are the very important topics. Okay, most weightage or most highlighted topics I can say. Even for JEE and even for NEET also, these topics are important. Right? Hope you enjoyed the session, and you can write your feedback in the chat box. Right. So we'll discuss or we'll meet in the next class. Thank you for watching. See,